Hi, this is Jeff Hamrick at Rhodes College, and we're going to continue with our attempt to compute the confidence interval for the true proportion of the time that we will see heads when we spin a coin, as opposed to flip a coin. We've already rejected the notion that the true proportion of heads that will come up when we spin a coin is 50%, 49% of the time, or 48% of the time. So let's go on ahead and try 47% of the time. We'll be rather systematic about this. This is rather tedious, but we'll eventually replace this process with something better. In this situation, our blue line is still to the left of all of the dots. The empirical p-value is going to be 0. We're going to reject the null hypothesis that the true proportion of heads we will see when we spin a coin is equal to 47%. So let's continue. 46%. Okay, now a few dots lie to the left of the blue line, but that's still 3 out of 500, and I know that's an incredibly small empirical p-value. I'm not even going to bother to compute the empirical p-value quite yet. We know that we have enough evidence to reject the null hypothesis that the true proportion of heads we see under a coin spin is equal to 46%. So let's continue. Let's try 45%. Okay, now in this case I'm a little bit less sure, so I'm going to go on ahead and compute the empirical p-value. I go to my measures box here. Okay, I'm going to define a measure. I'll call it empirical p-value, as I always do. And I want the count of heads that's less than the measure we saw with respect to the original set of data from the experiment. That was 325. As usual, I'm going to divide this by the count of heads. And I see that this empirical p-value is 0.034%. If I double this quantity and get roughly 6.8%, that value exceeds our traditional alpha value of 0.05. So I would actually not reject the null hypothesis that the true proportion of heads we see under a coin spin is equal to 45%. If you're not comfortable with the number of measures being collected with this particular trial, you can run this again and again and again and check it. Once again, this empirical p-value, when we double it, we get 7.2% this time. That exceeds 0.05, and so we would not reject the null hypothesis that the true proportion of heads under a coin spin is equal to 0.45. What about 0.44? Well, in this particular case, we get a huge empirical p-value. If we double that and compare it to 0.05, it will clearly exceed 0.05, and so we don't have enough evidence to reject the null hypothesis that the true proportion of heads that we see under a coin spin is equal to 44%. Now, that means we've established the fact that 45% can't be rejected, that null hypothesis. Neither can 44%. And we know that the sample data, which suggested that the proportion was equal to 41.67%, is going to be in our confidence interval. So we know that 0.43 will not be rejected, 0.42 will not be rejected, 0.41 will almost certainly not be rejected. But what about if we move to the left of 0.41? We're going to need to adjust the code here, but let me take some notes about what we've done real quick. Of course, this is going to update every time now. If I drop down a text box, let me make some notes to myself. The sample proportion of heads under coin spinning is approximately 0.41667. The upper bound of the confidence interval is 0.45. And we don't know the lower bound of the confidence interval quite yet. We'll get to that in just 1 second in one final video that we'll produce.